Welcome to Let's Weld Something. I'm your host, Bob Moffitt. Today we're at Terrace Welding Supply Sales. Going to meet with a gentleman here that has been in the business.
Hey,
It's
guys.
family-owned business.
Yes, sir.
Since 1974. 47.
47. If you're dyslexic, it's
I am.
That's right.
I am. I'm definitely dyslexic. Gary Lichtenheld, is that correct?
Yes, sir.
He's going to show us around the operations here, get to know some gas processes and procedures.
Correct.
Safety, all kinds of stuff about the business.
And a couple little stories along the way, too.
Hey, they're all
You're
good.
a wealth of knowledge.
They're probably
I heard.
true stories. They're probably true stories, right?
Fact.
All right.
Fact. We
Look
don't make
forward
up the
to it.
truth. Hey, let's go get it.
First question, I guess. You have all the liquids out here.
Mm-hmm.
How do we start? How do we get from liquids to usable and delivered to end users?
In gas or liquid to liquid?
In gases.
Okay.
Oh well, we go liquid to liquid. GP45s.
Let's do both.
In the olden days, I could roll 2 of those stainless GP45s empty.
Keyword empty.
I've rolled a lot of cylinders in my day.
So, good question, right? We got 11,000 gallons of nitrogen here, right? 3,000 gallons, 6,000 gallons, but how do you get it into a space that can be used? Well, it starts over here. And by the way, that's 3,000 gallons right there as well of oxygen.
Okay.
That is liquid to liquid to our customers in microbulk. So our supplier, Messer, comes in, they fill this guy up. So first thing that happens, this is argon, for example. Comes in here, we decide, what are we gonna do? We want gas or do we want liquid? If we want liquid, it's on the other side of this wall. That valve opens up and liquid comes down through here into the wall and we fill liquid to liquid. That's pretty straightforward. And again, we'll see it in a minute. If we want gas, then this valve opens up and comes into the pump and chills. First thing that happens.
I thought it was already chilled there.
Yeah.
Right.
This is 310 degrees below zero.
All right.
This is sitting here at 70 F. It's chilled right now,
Okay.
but the lower sump is not. It has to be, the piston and the rings have to be the right size relative to the cylinder or you're gonna score it, right? And that's not good because this stuff's expensive.
Right.
So the first thing that happens, it chills down here, a thermocouple feedback says, okay, it's cold enough, and this guy will turn on and start pumping, okay?
Mm-hmm.
And it pumps from here into this vaporizer. So this is liquid into the pump. The liquid goes into the vaporizer and just heat transfer into 70 degrees F.
So it's just turning in from liquid to gas.
It turns into gas,
Okay.
right? And then it goes down and up through the wall and over to our fill plant. Now, go ahead.
When it turns from liquid to a gas, is there a pressure increase? Is there something that's going on there that needs to be counteracted for safety?
Not just a pressure increase, more importantly, a volume increase.
Okay.
Right, a gallon of liquid is about 90 cubic feet of gas.
Woo, okay.
Right? So a gallon, 90 cubic feet at 70 degrees F, right? This guy controls the pressure. The feedback on the pump controls how much pressure,
Okay.
right? But the volume it can't control. Once it goes in here, it starts to build. Now, once it gets to a certain pressure, it's going to feed back to here and say, okay, you need to stop until that fill plant's running. Okay?
What happens to the volume? We're going to
Right. The volume sits in here until that head on the fill plant says, okay, I need some. Once it relieves this pressure, that feedback goes to this pump and says, okay, here we go.
Okay.
And as long as that back pressure is below X, it's going to keep pumping this thing until the back pressure, the computer in there, and again, easier to see it in there, but the computer in there says, all right, we're going to measure this thing to 1/10 of a gram.
Oh, that's good.
We're going to measure this gas to 1/10 of a gram. Now, when we're talking about putting 330 cubic feet in, This thing says, oh, we're a long way away from 2,400 PSI.
Yeah.
So we're just going to go.
Yeah.
Right. But as it gets more and more full, this starts going from to
down to, yeah.
Stops. Okay. And then we know exactly how much is in that cylinder by temperature and pressure. We'll get to that in just a second. So the gas comes in through here and up through the wall. So it comes through the wall here, right? This is the gas side. The liquid goes to this island. We'll come back here in a little while. The gas comes right through the wall here and up over there through the wall into the island. Now, this is a good time to start talking about safety, because obviously safety glasses, safety shoes, safety pressure, safety is really critical. Well, you look at these guys, this is heavy wall stainless steel.
Okay.
All right. Except this guy. Notice this one's a different color.
Yeah.
Why that is?
Not right off.
It's oxygen.
Oxygen and stainless, no reaction there, but, or is
theoretically, like bumblebees can't fly according to physics. Well, according to physics, with the right velocity and the right pressure, oxygen could spontaneously combust inside of even heavy wall stainless steel. It's never happened in history.
But what do you, spontaneous combustion, I understand all that.
Yeah.
Back in the old days, the argon or the regulator design, as soon as you turn the cylinder on, it would have that spontaneous combustion, and they got away from certain materials and valves and stuff.
Right.
So why? So what is it? I mean, why? What we moved to?
So what we moved to is Monel.
Oh, okay.
Monel.
All right.
So this is heavy wall stainless steel. Monel is $150 a foot.
But it's tinsel, and the chemistry of Monel is way
up there.
Nickel content.
Yeah.
High nickel. Yeah.
But it's $150 a foot more than heavy wall stainless steel.
Wow.
The upgrade back 11 years ago, the upgrade for this was just short of $30,000 just to go from stainless to Monel. However, this cannot spontaneously combust. It can't. It physically can't. And the people who work here have been here for anywhere from, a year to 40 years. They're our family. We can't have that. No. So it's Monel. Safety is critical everywhere throughout our industry, actually. I mean, with tens of thousands of cylinders, and that's just us, the number of incidents or accidents you see, it takes somebody doing something stupid a couple of different ways for something bad to happen, right? So.
And the number of valves and seats and everything else, every time, it's like a mathematical equation. Every time you do a transition or a transaction, you set yourself up for a mistake.
Right.
Every one of these, you're looking at all the connections.
Yeah.
Is this robotically welded?
It's orbital TIG welding.
Orbital TIG welding is what I was going to. Yeah.
It's all orbital TIG welded. Good time to talk about that. This system, we fill to about 2,600 max.
Okay.
26, maybe 2,700 PSI. Pressure, temperature, again, we'll talk about. But this system was tested at 5,300 PSI.
Time and a half, the nominal working time, working pressures.
Yeah,
I had
just
some
shy
of
of
the
6,000.
robotics or the orbitals in my classroom, the tests, and they were actually weld failures because of the color. There's too much heat input.
Right.
The controller,
the
controller was like $50,000. The Broody was one that in our area that I grew up in northern Oklahoma. It was like $50,000, but it would break up everything to within 1/10 of an ampere in 16 segments or 32 segments around this piece of pipe. Even though the pipe's that small, that was the control. That when you start out hot, you better start cooling it off as you went around it. So a guy could come in, after they do this procedure, he could make one weld and it was scrutinized and run his entire shift because of that right there, because of the
because it was locked.
Repeatable process. But
so that's how this was done. Now, Alcoa put this system in. That's the brain right there, by the way. The big box over there is the brain for this thing. That's the electrical panel, obviously.
For the sensors and whatnot.
There's a lot of calculating, processing going on.
Is it a live interactive screens that you can touch, like Siemens process, where you can look at volumes and look inside.
And you can look at it on your phone.
Yeah.
And it'll tell you. But
Fascinating.
when they tested the system, the fire department says, hey, can we be there? Can we be there? Like, sure, come on in. Well, we're sitting there and they use this blue gold. Have you heard of blue gold?
I have not.
It's a liquid that they use for testing this because it leaves no residue. Right?
Okay.
So they fill the lines with this blue gold, and then they have a high pressure pump. I think it's a 6,500 PSI pump, so it can maintain 53, 5,800 PSI. And we're sitting here and we're looking and we're looking and looking, and there's no leaks, there's no leaks, there are no leaks. And the fire inspector goes, well, what's that blue thing on the wall over there? Literally straight across.
Spraying that.
It sprayed straight across.
Because they had that much pressure.
The pinhole leak, and it was, that much pressure.
Oh my goodness.
I mean, the drop wasn't 2 inches, and it's dripping down the wall. That was the one leak we had in the whole system.
Unbelievable.
Hey, orbital TIG welding, like you said, you set it up right, and you can go the whole rest of the shift. And,
repeatable.
And you're good to go. So, all right, so now we've got the gas here coming to these heads, right? This head is for 580, so nitrogen, argon mixes. This head is only for oxygen. The threads, that's a 540 thread. You notice the threads are on the outside. It's a male thread.
CGA.
CGA 540. This one is
CGA 580.
580 internal threads. Right? So you can't use one with the other. Now.
Not supposed to be.
Not supposed to be.
Somebody figures out an adapter for an adapter. Yeah.
You know
and you read about them.
Oh, yeah.
That's about it. You read about them.
You know, even duct tape
Oxygen
won't
is
fix
that violent and complete combustion.
Yep.
You can't get that time back. It's done. Half second, it's over with. So,
but it doesn't burn. It just supports.
You can't light,
Right. You
but
can't light it.
Supports the combustion.
Supports combustion. So now we're up to a point where we're ready to fill cylinders, right? But I'm going to suggest, before we look at the process, let's look at the procedure. What happens to get a cylinder to that island with a fill head over it?
Okay.
What has to happen? Well, the way we work it is cylinders come in from our customers in the trucks. Everything goes on a pallet. Cylinders don't touch the floor here. The only place they touch the floor might be over there in the empty pile.
You know, I've always joked I'm hacked off at my mom. I was born in the wrong decade. I mean, seriously, I went through manual drafting. Right after I got done, here comes computer-aided drafting. I twisted thousands and thousands of bottles on the docks, 2 at a time.
Sure.
And then right after I get done with that,
you and me both, brother.
Oh, man.
Just about the time I got into
2 cylinders at a time all the time.
Yep.
Crazy.
But they don't hit the floor, so everything gets moved on pallets. So what happens is when the cylinders come off the truck, the first thing that happens is they get barcoded. So they all have barcodes, right? 2 barcodes per cylinder. The barcode is tied to the serial number on the cylinder.
I was going to ask about the serial number. You've probably seen some that have dated way back into the teens.
Sure.
It's like a CO2 cylinder.
Yeah.
You used to run across those every now and then. And they have to be tested every 5, or is it every 10?
It depends. If it's star rated or plus rated, it can be 10, otherwise it's 5.
Okay.
And again, that will show this is a star. That means it's 10 years.
10 years?
Yep. Unless, and part of the process is visualization, if there is the tiniest arc burn or sign of a flame, it immediately goes in for testing. If there's an arc burn, forget it. It just became a bell.
And you wouldn't believe how common that is on shutdowns and turnarounds, because they're up on catwalks and they have that grounded. Yeah. And something happens, they automatically. And what
or
do
they
try to hide it.
They take their TIG torch and throw it over the cylinder, and the capacitors haven't discharged, and bam, there they go. Right?
Yeah.
So they get barcoded. Now, if somebody scrapes the barcode off, that's okay. We got the serial number across, and they're also tied to the test date. So we know a cylinder at a customer that's out of test, we can go get it and get it in for test. So they come in on pallets. They're all brought to the island here, but they're brought to the island mixed up like those, right? Mm-hmm. And they come off, and the fill our fill captain takes them, and first thing he does is he rolls them off here and he inspects them. So he looks for arc burns, dents, gouges, scratches, grinder marks.
Oh, man.
Whatever it might be. They inspect them. He cracks the valve to verify that there's positive pressure or not positive pressure. It's important, obviously. If there's not positive pressure, then we have to treat them a little differently if there is, right? Because they can backfill with moisture, humidity, spiders, whatever.
So if a cylinder came in and the valve fully opened, that would be a concern. And we need to take that. Okay.
Yeah, that generally goes to the end of the island here and goes off to they're gone, but it goes off to retest right away. Now, the argon are a little different in that some of them, like this one, this guy here, here's a regular valve. That's a reserve pressure valve. This guy we don't have to worry about. When this comes off the skid over there, we check it visually, but we don't have to crack the valve because this is another regulator. Can you see it? Right here. This is a regulator
I got you.
built into the valve, right? So what this does is it says, we can't release any more. We have to reserve 25 PSI in this cylinder. Period.
And that valve takes care of all that.
It takes care of it.
Okay.
Yep.
That makes sense.
It's go, no go. Once it gets to no go, it's not, and it's at 25 PSI. So we know our argon coming on, and probably 80% of our cylinders now have RPVs, but.
And these are pop-offs that are built into.
Yes, that's right. That's the safety. So if this gets overpressurized, either here or in the field, more likely, from heat or whatever it might be, that will release.
I've never seen one pop off. Never had one pop off, even though we've been out in extreme heat of 110 degrees working in it. I've just never seen one pop off, I guess. And that's okay by me.
That's great. Good for you. I was at a fill plant in LaGrange Park back in the late 70s and just happened to be there and loading up a bunch of CO2s. And one of them, not the one where I was working, but 20 feet away, just decided to let go. And when I say let go, there's a seam in this cylinder that is weak. So these are spun.
Right?
Yeah, they're taken from a billet. They're taken from a solid billet, and they're heated and spun. And sort of like a
extrusion.
Extrusion or a guy working clay, right?
Okay.
It just moves it up. While it's doing that, there's a bore going down the center that's pushing so that it forms this cylinder. When it's done, they put the dimple on the bottom, they roll the shoulder up to here, then you put the cap on and off it goes.
How is this attached? Everybody asks, how's this attached up here?
Generally glue. Because this is nothing more than a shoulder protector. It's the threads, the neck comes all the way up to here.
Okay.
And then, so you can see it right there, right? That's the neck of the actual cylinder itself. It stops right there. This just goes over the top. It is a weak point, so you put that in there. So you thread this guy in, right? You're set to go. But there is a weak point, launch it vertically in the cylinder so that if this fails, this is made, rather than to shatter, it's made to open up.
Blow out.
Yep.
But retain itself.
Exactly.
Stay within itself.
One piece.
Yeah.
I'll tell you what, that will change your pants.
Yeah, I would imagine. That.
But the safety is incredible. When this has a cap on it, and we're sitting at at a recessed dock or sitting on one of our trucks and 6-7 feet off the deck, it falls. Let it fall.
I'm sorry to admit it, but I've knocked about 20 of these over on the dock because our dock was so beat up.
Oh.
Depressions in the concrete. You'd be twisting two across. I'm unloading 2 semis a week. You're twisting out, minding your own business, and you hit a rock or you hit one of those big depressions or a patch of ice or something. If you let go of one, just let go of it. There's no point in trying to save it, and it bumps into another one. It sounds really bad, but I've never had it. I mean, they fall over, but if the caps are on.
I have never, ever seen or heard of a cylinder falling off a truck from any distance or falling anywhere and the valve break.
Right. I haven't even, not with cap on correctly. I've never
Nope.
heard of that. Now I've seen them where this is falling over and cracked because of not having the cap on it.
I've seen when they were building Lake Point Towers in Chicago, right along the lakefront. I happened to be down there, and it was lunchtime, and the contractors are laying cylinders down, oxygen cylinders down, between two rocks, right, and then taking another rock and dropping it on the valve.
Why?
Shooting it out into the lake.
Like a torpedo. Oh my goodness, recreational.
Yeah, that's all it was. I'm like, guys, you don't know what you're doing.
Holy smokes. Wow.
Saw the result of an oxygen cylinder at a customer. He didn't have a cap on it. He was walking along trying to roll it without a cap, and it was full. Right? He already had the empty over, had it full. Dropped the cylinder. It went through the brick wall, a quarter mile down the street, like this, and lodged half in and half out of another brick wall of a restaurant.
Wow.
Yeah.
You know, they're like firearms. You put two of them side by side. You cannot tell which one's full, which one's empty. You put the caps on them all the time when you move them.
Yep.
I've quietly gone into restaurants and they have helium or something at high pressure. Mm-hmm. It's not chained up, and I'll ask for the manager immediately. You know, and they think something's wrong. Well, yeah, something's wrong, but just give me the manager. And I quietly ask them, have you ever seen the results of a cylinder that is knocked over? Because it'll remodel this. It doesn't care. Human flesh or brick walls. It doesn't care. It's going to go through it.
It's gone. Yep.
And then I had a bracket designed on a CNC that had the little hooks went on the wall, and
for the chain.
I built a bunch of them for free. I don't care. I'm just wanting people to be safe and aware that, golly, these things are dangerous. So high pressure, you bust one of those off, it's, what is it, 2250 trying to come out of a 1-inch orifice, it's going to have propulsion behind it. And how much do those weigh now? 180 pounds or so?
Yeah. Yep.
So they weigh as much as,
up to 200, depending upon which ones.
I don't want to, if it falls over, I don't want to I'll try to save it a little bit. Gee whiz. Like I said, I've knocked over a bunch of them, and it was just, the condition of our dock was not smooth. It was bad.
We hear cylinders fall, not very often, but you hear them.
It's alarming.
We have one question. Everybody okay?
Yeah.
We know the cylinder's okay. Everybody okay? Get your fingers out of there, first of all.
Oh, yeah.
Because, they hurt. But everything in the plant is it doesn't have to be. As long as it's nested, that meets OSHA. Nested means the cylinders have 3 points of contact. Right?
Strapped.
But we still strap them.
Yeah.
We still do, just because you got to. All right. So now we've gotten the cylinder from here. We've visually inspected it. We've cracked the valve and verified what contents are not in there. And then we sort them into each of the cylinder types. We fill a bunch of cylinder types. This is argon oxygen, for example. This is argon CO2. Now, everything on the pallet has to be the same. Gas. But we can fill a 330 cubic foot, 150 cubic foot, an 80 cubic foot, all in the same pallet. Because the program knows it. Says, okay, I've got 80s in here, I've got 150s, and I've got 330s. So once it gets to 80 PSI, it says, stop, close the valves on the 80s, and then you hit the button again, and it'll fill the 150s. And it'll stop, and then you can fill the 330s. It's really kind of cool. But we've got them over here now. And, back in the day, if you worked in a fill plant...
I didn't ever work in a fill plant, but...
Well, the old fill plants were kind of a wall of gauges. And a bunch of handles you spun. And it was a 3-ring circuit.
Manual.
Yeah, all manual. Now it's not. But the biggest problem was carpal tunnel, because you're doing this on 18 cylinders, and then
don't spin like that either.
No, and then you've got the connection here. So you got to open them, close them, but you also have a nut here, right? Normally, you have this guy coming down, and you have a nut. Well, these guys, there isn't. When we're ready, that's it. That cylinder will take 5,000 PSI and not leak one molecule.
Wow. Does the computer tell the when is it safe to release? Does it know when that valve's closed? And
it knows, right? It knows which cylinders have one of these connected.
Okay.
It doesn't know if this valve is open.
Okay.
It can't know that.
But can this be released if there's
No.
pressure? Okay, that's what I'm asking.
Yeah.
So there's
No, once
so
you
there's
get
a mechanical
pressure on
thing
this-
going on in here that says,
once
okay,
you get pressure on this, it
Yeah.
locks a sleeve in place,
Okay.
and you
Can't
can't
release
lift
that.
that up.
All right.
Yep. But that's all it takes now, right? And by the way, if we're filling a cylinder bank of 12, right? We just connect the whole bank to
Right.
this. But that's what the nut used to look like. You had one of those for every single cylinder.
I had a system in school when I first started. It was 10 oxygens, all piping through a 1-inch orifice that actually went through my office. There's no safety shutoff. There's no emergency shutdown on the 10 oxygens. And
On a manifold.
On a manifold system.
Wow.
And I thought, I don't want to operate this, especially going through my
And
office.
especially oxygen.
Oh, man.
Right? All right. So now we've got the things hooked up. We've got it set. Now we're ready to fill. I know it's taken a long time, but it doesn't really take that long, right?
Yeah.
So now we're ready to fill. So we go over to the head here, to the brain, right? And you say, okay, we're ready. You load in what cylinder type, what gas you want to fill, what blend. We can do a 3-part mix, we can do a 4-part mix or a single, and then the sizes. You load it in here and you hit go. That's all you have to do is just hit play. And then, remember that we were out at the pump?
Mm-hmm.
It says, okay, that signal goes up, over to the computer, out to the pump. It says, all right, start putting argon. Actually, we put CO2 in first. This is argon CO2. So we put CO2 in first. Why would we put CO2 in first?
I don't know.
It's heavier.
It is heavier for sure.
Yeah, because under pressure, it's a liquid, solid, or a gas at 70 degrees F. It's the only one that has a triple point there. But it will sit in the bottom. Right? So it sits down there. So you want the argon to go on top of it because there's a lot more of it and it's going to mix it up.
Right.
But it's not going to mix it up enough. Back in the day, you had to take these and roll them.
Yep.
Remember?
I remember that.
Well, not anymore. This cylinder valve has a stainless steel tube that goes all the way to here.
And it shoves some of that argon up underneath the...
Everything goes through it.
Yeah.
Everything. The CO2 goes through it. And then when you start dumping argon in, it goes through it. It bounces it off the bottom of the cylinder. And I'll tell you what, that is one homogeneous mix. It does not stratify ever again. So, you put in you hit play, and then what? Well, the first thing that happens is these are all open, right? Those are sitting there, they're all open. The valves here are all open. First thing that happens is that thing opens a valve in here, and anything in these cylinders gets evacuated. It just dumps out the atmosphere. Goes up, the copper pipe over there, 2-inch copper pipe over there, goes up into atmosphere, right? And then you stop. And then the vacuum pump down there turns on, and we pull a hard vacuum, right? And once we do that, we stop. The pump turns on, and we fill with argon up to 100 psi.
Okay.
Okay? Stop. Dump. Dump it all out again.
Really?
Yep.
So you want to just purge that tank and make sure that there's nothing else in there other than what the volume of argon or whatever that...
If we're doing argon, for example, or oxygen or straight nitrogen or whatever, it's 99.995.
Right, for just standard.
For standard.
The high pressure, high purity is add another 9 in the decimal.
9, yeah.
Ultra high is,
right.
Okay.
But 99.995 is pure. Ultra high pure is an extra 9.
And in that decimal equation, the 0.995, it's a little bit of what? Moisture, parts per million of what's the...
Of something other than straight argon.
Okay.
Right? And it could be nitrogen, because nitrogen is at 320 degrees below zero. Argon is it condenses out at 310. There could be theoretically a little bit of nitrogen in there.
But
it's inert, but it's not. Yeah.
Right.
But it could be. The gas chromatograph doesn't care what's in there. It just knows that it's something other than argon.
Okay.
Right. So we put 100 psi in, dump it, pull a hard vacuum again, and then we start filling.
Wow. I mean, that's a lot of good stuff. I mean, you're making sure you're delivering the pure product.
We don't have to do that. We don't have to, but that's the way we do it.
Nice.
And all good distributors do it that way. There's one more step that is really important, and that is this. That's a thermometer.
Okay.
That's a thermometer. And it sits on the
Magnetically
outside.
held to the-
Yep, magnetically held to the cylinder. And it has a feedback loop to the gravimetric scale in that box. That gravimetric scale, as I said, is calibrated to 1/10 of a gram. And it's calibrated every year.
God, that's tight.
Yeah.
That's
Well,
tight. Wow.
You got to do it right. So this guy, as these fill that cylinder. That was filled about 45 minutes ago.
That's warm.
It's warm, right? As you fill, friction creates warmth, right? Creates heat.
Feels quite a bit cooler.
Yep, because these haven't been. When you extract the product out of the cylinders, it cools down. But as you fill them, it gets hot. Well, when we fill to pressure and temperature. There's a whole bunch of charts, I can get them for you, but at say 2300 psi and 80 degrees F, that might equal 330 cubic feet, whatever. But there's a pressure and a temperature that together,
To
when
get
they
to that.
cool to 70 degrees F, it will equal the cubic footage that we're selling in the cylinder. But there's one more step. We know through Weld and the industry, through GATA and the rest, that the cylinder wall thickness of this guy will read 4 degrees cooler out here than it is in there.
Okay.
So the gas is all in there. So if the gas is in there and it's 4 degrees hotter than out here, and our computer is calibrating on this temperature, we're cheating our customers.
Yeah.
So this is calibrated 4 degrees hot. So when we say 330 cubic feet, you're
330
getting
feet on the inside wall of that.
at 70 degrees F.
Interesting.
Done. So it fills, and as I said before, that pump is going to go until it gets to 330, and it just shuts itself off. At that point, you're ready to release them. You put the caps back on them, spin them, and you put them into inventory. But before you do that, I forgot to tell you, when it goes from this side of the island to this side of the island, it gets barcoded again. When it goes from this side of the island to inventory, it gets barcoded again. When it goes from inventory onto a pallet to the customer, it gets barcoded again, and it gets barcoded onto the truck.
Red or attached?
Red.
Barcoded.
Barcode.
Barcode.
We're able
red.
to. Yeah, we've got a
Okay.
reader on the phones, so they just.
Interesting.
And when they get to the customer, they can say, okay, this one, and that one are going to that customer. And we're getting these 4 or 3 or 4, 6 or whatever back again. So we know for 10 years, every place this cylinder's been.
Yeah.
Go ahead.
I was going to ask what is in place these days for, you hear about in the pool, and do you buy your cylinders? Who owns them? Who does what? All this.
Yeah. That's a great
back in
question.
those days, my dad and I had an account for his independent oil business, and we put a deposit down for the life of the account. Okay, so
Right.
essentially, I put the money down for a cylinder of argon or oxygen, and a cylinder of acetylene. We didn't own them.
No.
They still belong to Jimmy Jones and whoever,
You
and they
basically
did the
leased
testing
the right
on them.
to exchange
But
it.
when I turned one in, I took another one out of the pool.
Right.
But I did that by depositing. And when I quit as a customer, they said, "Hey, I'm done. I'm moving off somewhere," and they refunded the lease amount.
Right.
And I didn't pay demurrage. I didn't pay rent.
Right.
So
that's
tell me
why you put that. So those are the two ways. Well, first off, what's in place to protect, right? Federal law. If I am convicted of filling someone else's cylinder that I'm not authorized to, $10,000 per cylinder and 5 years in jail.
Oh my goodness.
Now, you look through this whole place and find a competitor cylinder. I dare you. You're not. The only time we would pick up a competitor cylinder is when our customer writes us a letter and says, would you get this back to the people who...
I've done that so many times.
Sure, exactly.
It's crazy.
Yep.
You do it.
Yeah.
Even though you're competitors, you do it.
Yeah.
You know.
Well, but you know the good ones and you know the other ones, right? So that's federal law. Does it stop people? It stops us. But then there's the 80 cubic foot cylinders and below. So basically, any of these, right? And anything this size and lower are what are called generic cylinders.
Okay.
From a DOT, from a Department of Transportation perspective, they're generic. So if they have our neck ring on them, it doesn't matter. You can exchange those with anybody who has, basically anybody who has one. They bring one in, you can exchange it for them. 80 cubic feet and less.
What do you call these little R's?
R's. Yep.
See, there's a whole language. You know what I call a K,
right?
Other people call it a medium. And then I've had
T.
vendors that they want to go 381 mix or something.
Right.
That's their argon.
Yeah.
A&Es go on the ambulances, the tall, skinny oxygens.
Yep.
You know, I had all those, and I call them, you know, the S size cylinders. 125 cubic feet
125,
or so.
yeah. Those
guys back there. I use those a lot on the 110 volt inverter type machines.
T size?
T's 330, with the big
K
T's.
was the oxygen.
T's, K's.
Yep.
And what was below the K? I can't. There's the S.
He went to S. Yeah.
And then below S was
was 80.
Okay.
Yeah. Or Q and WQ.
Q. That's what
Q
it was.
was Lindy. Lindy was Q.
Right.
And then WQ was the oxygen. Was the acetylene.
I remember now.
So
it's been a long time.
The other thing that happens when they come off the fill island before they go into inventory is they get one of these.
I saw that for the first time last night.
Their heat shrink wrapped on there. And they do it for a couple of reasons. The biggest reason is if a customer puts all their cylinders in the same pile and they pull the cylinder and like, oh, you had an empty cylinder. Well, did it have a wrap on it? No. Well, that was an empty cylinder because you already used it, right? So you right away know that this cylinder is brand new. It's full and it's brand new.
And I have run across them they're empty. That came and sold as full. Yeah, it happens.
It happens.
You know.
And shut that thing off. Don't. But if someone calls and says, you know what, I got an empty cylinder, are we going to argue with them?
No. Well, if it has that on
the first time, not the second time. The next time we might actually say something.
If it has a shrink wrap on them, I'm going.
Well, then for sure.
Yeah.
If it has a shrink wrap, you just trust. I mean, come on. But it's a lot of trust. It's a lot of faith. But doggone it, I'm not filling somebody else's cylinder. I don't know where it's been.
Yeah, that's the thing. You don't know where it's been.
Yeah.
And I had to do collections on a lot of stuff. The buy-sell agreement in between Oklahoma City and the Punk City area. I had to go do collections, and legally I have a right to go in and put a wrench on your cylinder.
Sure do.
And I had a shotgun pulled on me one night, but that was the only real incident. Took my dog with me. I took the sheriff with me. I got real good on how to find people because I would go to the postman and say, well, I'm going to tell my stories now. For all you folks that I collected on years ago, I was still honest and ethical about it. I'd go to the postman and say, my company made a mistake. I'd like to go apologize in person. And I'd ask where they were because they weren't going to tell me before that.
No.
Oh, yeah, you can find him out 3 miles west and 2 south. And,
Go to the oak tree, turn right.
I'd go out there. And first off, I'd have to apologize for the disparaging letters that corporate would write.
Right.
And, say, hey, you got some cylinders. I don't care about the balance. I just want the cylinders. I got to get them back in the pool, come on in. 99% of the time they thank me for showing up because nobody would ever give them that service. And I'll tell you, I found people deep in the woods. And one of them was an old Quonset hut. And I knocked on the door and this guy wasn't answering. I said, I'm getting back in my truck. He said, is there something I can help you with? And I said, yeah, I need some cylinders. This is the only place around. He goes, yeah. It's the right place. Come on in here. I walk in this. It's got dirt floor in the front. Keep walking further back. Gets nicer and nicer. And we get clear to the back. There's a hot tub underneath the stairway. We go up into this immaculate, beautiful kitchen. I mean, it was not. The guy's living off the grid.
Yeah.
That's why barn dominiums were. That's how barn dominiums came around.
Yeah.
I told him, who I was, what I was doing, and I said, I don't care about the balance. I really don't. I just want cylinders. And he wrote me. I'm glad you're here. Wrote me a check, full balance and everything. And I said, I got a wrench with me. I said, by the way, I was never here.
Right.
He goes, come back anytime. I like you. I know what they're doing.
But it's attitude. It's attitude.
And I'm collecting cylinders. That's all I was doing was collecting cylinders.
Human nature.
Because people, they forget about them.
Right.
But again, they're going out of test date. They're not going to do anything but sit. So what good are they? You need to get them back in service.
Well, and then there's
write them off.
Somebody stole. I returned them to you. I returned them to you. Well, that doesn't work because they got a barcode on them, and but someone stole them. Okay, you got to pay loss of use, but when you pay loss of use, it's loss of use. You're not paying for the cylinder. It just means that we can't use that cylinder for now. Right?
Yeah, how many people have you had to get them here and they go to Texas and contract a job? They leave them in Texas.
It happens.
I mean,
it happens.
Yeah.
These are paper bags. You talked about I don't want the balance. That's a $400 paper bag, right? We put the product in the paper bag, we send it to the customer, and we just want the paper bag back. Right? We want to get paid for the product, but we really want that $400 paper bag back.
Yeah.
It's expensive. And by the way, they take about anywhere from 10 to 20 months now to get them custom made, because ours all have our serial numbers stamped into them. So
the stamping, not necessarily the collar that doesn't.
The neck rings they've got hundreds of those, but it's the stamp on the cylinder coming through the plant.
The plant that's making them.
Once they are done, they get stamped right away, and they got to have our number on it and our sequence.
The penalties for hauling without a cap are, I mean, we're strict on that now. Didn't really used to, but so it's a big
fine.
Big fine to the driver, but it's a bigger fine to you.
Yeah, but like you said, the biggest problem is the driver, because they'll lose their CDL.
Oh yeah, how hard is it to find? How hard is it to find good personnel these days that have a CDL, that have anything that they're qualified to work for you for driving? In the Chicago area, I wouldn't think it'd be that tough.
How many hen's teeth have you run across in the last 2 weeks? It's tougher than tough. And the competition is crazy. The advantage we have is we're a family company. We treat people like they need to be treated. We pay them fairly, but we're in this together.
Yeah.
So it's very difficult. But if we can get them to the door, we got a good chance of getting them.
High pressure air, you don't do anything with the air like the fire departments and stuff?
No. Compressed air. We sell it. We don't
That's a completely different animal.
It is a whole different animal.
That cylinder is so thick and so heavy.
Yeah.
3,500 PSI.
Right. Yep. Yep.
I had to.
So really, like I said, the actual process of filling a cylinder is really quite simple. You push a button.
Now, I mean, you have it computerized too.
When you got one of these.
You described the days of the all manual valves and spinning this and that. How many shortcuts could have been taken back in the old days and problems that could have come around? A lot.
Overfilling, underfilling, it's all over the place. One thing we didn't talk about is we've got all this gas around here, right? And curiously, our tolerance for too much or too little CO2, for example, 2% too much CO2, you go to sleep.
Oh, really?
Yeah.
Okay.
Too much oxygen, you're out. Too little oxygen, you're out. It's very tight. So multiple places through the plant, we have these. It's a pure air, it's a constant gas monitor. It monitors O2 content. Okay. Just O2, because that's all we really care about, right? We have a CO2 monitor too for over that, but it doesn't matter. If the CO2 is too high, then the O2 is automatically too low, right? So when this guy goes off, if it gets 1.5% above or below, the alarm goes off and the HVAC here and throughout the plant light up. HVAC starts bringing in fresh air.
Okay.
So it continually monitors everything going on. And the nice thing is those are sealed. So we only calibrate those about every 5 years because moisture doesn't get into them. There's another style that's inexpensive. Those are about $2,000 a piece. There's another style that's inexpensive, but it has to be calibrated every 6 months or, you ready for this? Humidity change.
No, stop it. That's an hourly occurrence for crying out loud.
Oh.
Wow.
So dry ice. What's dry ice? CO2. All it is carbon dioxide. That's all it is. We talked about the triple point, liquid, solid, or a gas.
Right.
Well, a liquid is what's in that bulk tank.
Okay.
A gas is what's in the air. And a solid is right here. That's solid CO2.
And frozen extruded through a plate that gives it that shape there, and that's
Yes. Yep. So what happens is the liquid comes into here, and it goes through a vortex into a chamber. The vortex expands it really fast, okay?
Okay.
And makes it into snow, very dense snow. And then the ram, we got 120 gallons of hydraulic oil in that part. Ram comes and compresses that into a solid and then shoves it through a 1/2-inch stainless steel plate.
Okay.
Either 16 millimeter or 3 millimeter.
Straws.
It's called rice
What do you call
for
them?
that reason.
The temperature of the product as you touch it.
90 to 100 below zero. According to our illustrious government, that's not cryogenic. It has to be less than 100 degrees. Why couldn't you make it 90? Because this is equally, but whatever. That's our lovely. But the interesting thing on this is it's called dry ice because as you look at it, it's not melting, it's sublimating. It goes right from a solid to a gas. It doesn't go to a liquid. Like ice will go to water and the water will evaporate.
Right.
There's no water on my hand, but it's going away, right?
It's vaporizing
It
itself.
goes
So when it
right-
changes states,
Exactly.
it goes back to a gas.
But it skips a step. Technically, there's a microsecond it's liquid, and then it's vapor. So hence dry ice, which is really great because if you're shipping things, right, and you're using those liquid, the ice packs.
Styrofoam, yeah.
Yeah, your styrofoam and then an ice pack.
Salmon, lobster.
Yeah.
Yeah.
As the ice pack melts, the package gets heavier because the condensate on the outside of the pack, the air around it, the humidity condenses, creates water on the outside, plus the liquid on the inside. Whereas this actually gets lighter as the package goes across. So both of these are used for packaging, shipping, medicine, but a lot in food service, right? They think of making sausage, right?
Okay.
You take the meat, you put it into a vat, and you got to mix it up.
Yep.
Well, that auger creates friction, which is heat,
Oh, that's right.
and that'll emulsify the fats in the meat.
Yep.
So they literally take dry ice and throw it in the meat.
In the meat to keep the product cool as it's
it
doing
moderates
work.
the temperature. Yep. And then it goes away to nothing.
Yeah.
Doesn't add moisture to it, doesn't add water to it, doesn't add anything.
Yeah.
It just goes away. It does add a little bit of acidity, which is okay when you've got the spices and all that
That are
stuff.
living through chemistry. You counteract that with something else.
Exactly.
Interesting.
By the way, there's a lot of swimming pools now using CO2 instead of acid.
You can get a dry ice burn by just
Yes, you can.
keeping it one spot all the time.
Yes, you
so
can.
I gotta try hard to get moisture off of that. I mean, I can kind of feel it, but
Yeah.
it's not.
No, that moisture is coming off your palm more than off of the ice.
Yeah.
Yeah.
It really is just sticky.
The
Changing
right-
the temperature of my skin is what it's doing, and that's probably
Yes, it
it
is.
gives me a sensation of being wet,
Correct.
but it isn't wet.
Correct. It gives you a sensation. One of the big uses for WeatherTech, the WeatherTech floor mats, they buy, I'm not going to tell you how much because it's a lie. They buy dry ice from us, and they take the mats, when they're, after it come out of the press, they have the flange around it, that thin flange from the mold. So they take ice and stones, and they put it into a big tumbler, and they tumble the mats in there, and it
We were talking
fractures
about
off.
that. We were talking about that way on here.
Yeah,
Blast media
Right.
creates indentation and work hardens materials and stuff
Right.
like that. So
which brings up another big use for rice. This thing that I never knew about until we got this system was this thing called dry ice blasting.
yep.
So sandblasting, we all know sandblasting. We use it for mold remediation, chars on burned buildings, whatever. But mold remediation, where's the mold, right? Mold is either up in the attic or it's down in the basement. So you sandblast and you go, wait a minute, I got 500 pounds of sand. I got to take it all the way upstairs. I sandblast the wall. Now I got to sweep all this stuff and carry it all back downstairs again, right? Or the basement, and I got to carry it back upstairs again. Dry ice, you blast it, and you sweep up the mold, and that's all. There's nothing else left.
How do you move that? How do you package that? Just in that container alone, or how do we work with it?
Yeah, exactly. Let me just finish one little thing about that mold thing, right? When you sweep up the mold from dry ice blasting, the mold is dead. When you sweep up the mold and collect it and take it downstairs with sandblasting, the mold's still alive.
Not good.
It hadn't been killed. So It just goes somewhere else. How do you package it? I should have brought a blaster in here. A blaster looks a lot like a 250 amp Miller power source. It's about this wide, this long. It's got a hopper in it and it's got a wand. You've got these Yetis, right? 500 pounds. You pull them out, you shovel into this hopper.
Okay.
And the hopper grinds the rice depending upon how fine you want, how aggressive you want to be. And then it's just PSI and CFM, right? Compressed air, just like sandblasting. And you shove it through the nozzle.
Let's say we want to go 100 PSI, and so it's CFM after that is how much volume we can actually blow. So
one is pressure, the other is about how much.
So how much? What's a typical application? 7, 15, 20 CFM?
You're
low?
talking about more 80 CFM, depending upon, look, dry ice blasting, you can cut a 2x4 in half.
Wow.
Or you can take the ink off the business card and not hurt the business card.
Violate the integrity of the card.
Right.
Okay, so that's making sense.
Yeah.
So like a typical die grinder application in the shop, I'm using a die grinder. It's like 15 CFM.
Right. Yeah.
Okay.
Yep.
No, CFM, that's right.
But those little guys cost about 40 grand.
Wow.
The blaster.
Oh. So you make some good money with them.
We rent them, yeah. You bet. All right, getting pretty loud in here probably for the camera.
Well, let's step out, go over to the supply area. And
sure.
We'll culminate.
Yeah, let's go this way.
Okay. Is that a volume type?
It's pounds per hour.
Pounds of dry ice per hour.
Yeah, and we're about 1,500 pounds an hour.
Oh my God. That's
And we have another machine waiting to be set up.
How is dry ice sold? Is it by the pound?
By the pound. Just by the pound. Yep. This is some of our wire that is packaged for us. And this is just a little bit. The bulk of it is in Villa Park, in our other location. RoboPacks. Yep. Just MIG wire. Oh yeah, it smells like money.
Smells like S6. Oh yeah.
It smells like money to me.
Yeah.
So, and then we have this is our rental shop. So everything gets tested before it goes out, and it gets tested when it comes back in. So everything gets bench tested. We got an exhaust fan. Awful lot of stuff out this time of the year with shutdowns and the rest. Most of the big equipment's in the back. But
you're doing things that a lot of people just don't do. They don't do them. They don't run anything anymore. They don't pull the trigger. They don't know what things are supposed to look like. This is admirable. I like the fact that you are running the processes and see them. And
well, we love having people demo. We also, in our other location, we have a repair shop that's 4 times the size.
Now there is a business, a whole nother business I've been trying to push young people to get into. You can write your own ticket.
You can write your own ticket.
People, we have GE jet engine repairs right there, right by us, and they don't have a problem writing a $12,000 check for about 3 days worth of work.
Well, I look back to my grandfather who started this business 75 years ago. He started out in a foundry. He owned a business, foundry business, and it went bankrupt in the Depression. He spent about 10 years paying off the bankruptcy, started his next business. Now, if you're a foundryman, what would your next business be? A grocery store.
Yeah.
I don't know. So he started Maywood Grocers, but then all the big chains started coming in.
Yeah.
He went bankrupt again. He spent another 7 years paying off the bankruptcy while he was working at an auto parts store. 51 years old with a 14-year-old daughter and a 7-year-old son. He says, Gertrude, that's my grandma, I think we ought to go in the welding business. And at 51 years old with 2 bankruptcies, he started this and made most of his tools.
Yeah,
I've got a bunch of them.
That's another one. That's another thing I like to do is make a repair tool. I've got a bunch of stuff from my dad's I'm redoing.
Yep.
The old spoke shape.
Yeah.
Draw knife.
Oh.
I got a bunch of old stuff. Bracing bit.
Right.
And somebody just handed me a box, a big old nice box of bracing bits. The bits. I couldn't believe it when they handed it to me.
You can buy those for $5. People don't know what they are.
They don't know what they are. And I don't want to blast them. I want to dry ice blast them. That's what I want to do. I'm finding somebody to take that off there because they would look pristine.
Yep.
And I'd have to lightly oil them and they'd be there for again. There's bits in there. How are they made? They're this long.
Oh, yeah.
They're exactly straight. How did they make those screw bits?
They're all forged.
That's fascinating. See,
it's all forged.
That's what I'm trying to get into.
And that's how they get the tensile strength in them. It's incredible. Yeah. 320 degrees below zero now. Obviously, over time, it gets a little warmer. It boils all the time. Like in here, whether it's in one of those vessels, out in that bulk tank, it's boiling. We can't keep it at 320 degrees below. But we can keep it in liquid. And you want to come up close here. Really close. And what you want to watch is the neck right here, and you'll see the water coming out. Can you see it? There. You see that water? That water, now if you look back, look down, there it goes. It's really good on a day like today that's humid. That water is 300 below zero. See it right there? That's liquid nitrogen, right there. I'm not touching it because it's still really cold. That's liquid, it's black because it's picking up all the dust on the floor. But that, leave it right there. There's still some over there. There you go. You good? That's the paint. Yep. So that's liquid nitrogen. And it's used for everything from cryo spa to laser cutting.
Wart removal.
Wart removal. Lots of it. I have one of those guns.
Skin tag removal.
Yeah. A good friend of mine actually has the gun. I have the nitrogen. It's a good plan. That's it. Still wandering around.
It's also used for what was the first you said? Cryo what?
Cryo spas.
Cryo spas.
That's, people stand in there and go to 250 degrees below zero, and it's supposed to be good for your skin and muscles and whatever.
Metallurgy. Mizuno was one of the first to do cryogenic heat, where they take a forged club down to and let it set.
Yeah.
Rearrange the molecular structure to near perfect when you're talking about when you're talking about the carbon and the iron molecule, the interstitial space, it'd move that where there's no voids or whatever.
Yeah.
That's why Mizuno clubs will feel like butter when you hit the sweet spot.
Well, it tightens up the super skin, but it stays malleable underneath. So it really does work. The other thing really good about liquid nitrogen in golf is you take a golf ball and put it in a cup of liquid nitrogen and just let it sit there. 20, 30, 40 seconds, maybe a minute, it's going to go in half. Okay? Then you take that golf ball and you get 3 little dots of super glue and you put it back together again, take some white out around the edge and you put it in your buddy's golf bag.
Yep.
That's fun. Because as soon as he hits it, it goes.
Now you know.
That's fun.
Minus 240? Is that?
This is probably sitting around 280, 290. It's 320 when it comes off the air separation.
When you're working with it, the safety procedure, you're doing full mask, full gauntlet gloves, full
headgear with earmuffs and cryogenic gloves, not regular gloves. Cryogenic gloves are like $200 a pair, but they work and they're worth it. So the blue ones you saw in the dry ice room are also cryogenic gloves. But one thing we didn't talk about is these cylinders. So you have a pallet of cylinders there, roughly 18. That, if you see the cylinder right over here, this silver one,
Yeah. GP.
One pallet like that is in there. Yeah. Liquid, gas. So you move a cylinder 14 times, or you move this in once, and it's there.
330 cubic feet times
14
equals 4,500.
Yeah, 4,500. Yep.
Yep.
Now, the next step, if you look up there on the rack where it says carbon dioxide, that cylinder is 3 of those.
Yeah.
Right? Those we put at the customer, and we bring that truck. Remember the way in the beginning I said there's a 3,000 gallon oxygen on a truck? We take those out and fill Lin locks and locks.
That's heavy, heavy, heavy.
Heavy, heavy. Yep. And then you turn here, and that's 1,000 liter, a 1,500 behind it, and a 2,000 liter. And so that is, what, 12 of those, I guess? 450, yeah, roughly. Yeah, about 12 of them. And then we go up to 5,500 liters. So basically a 1,500 gallon bulk tank, and we can fill it off of our portable trucks.
I had to fill a hospital bulk off of one of our off the truck every other week or once a month or something, and I hated it. I just didn't like hauling that liquid oxygen, that bulk liquid oxygen. Never felt comfortable with it, you know.
Yeah.
And you know,
in and of itself, it's not dangerous, but it's very dangerous. It's still 290 below zero.
Right. You're driving along, you get people that creep out in intersections. I show them my hands. I'm not going to swerve for you. You can go ahead and pull out there. I'll breed you, but I'm not going to swerve because I have liquid oxygen on board. And
yep.
I've actually seen some of those tumble out of vehicles where they didn't have them tied down correctly. They just kind of got lazy and didn't put the right tie downs on them and turned the corner and watched them fall out. But that's why they have that stainless ring around them.
To protect,
and you know what would happen if something broke off of that? It's liquid. It's just gonna vaporize off. It's not gonna be like a high pressure cylinder.
No, not at all. That thing's under tops 500 psi.
Yeah,
probably closer to 2.
So next question is, how much do we lose? Let's say that I'm coming up to Brian's place and I'm gonna do a lot of fit and fab, and I say, well, just give me a GP45 argon, do all my TIG welding with. How much am I gonna lose if I'm not using it? If I'm not using it, what am I losing when it warms up and it's boiling off? And
in a regular 180 liter guy, once you've taken the head pressure and maxed the head pressure, it generally takes about a day or 2 to max the head pressure. Once it hits there, you'll lose 1 to 1.5% a day.
1 to 1.5%
of the capacity of the what's in the cylinder. Yep.
Okay.
It's compared to the labor rate of moving cylinders back and forth.
Yeah.
It's pretty darn good.
Yeah.
Yep.
Didn't look at it that way. That's
those cylinders up there, the micro bulk, that uses the same super insulation that they use on the shuttle. They use it for heat, we use it for cold. But those will go 10 to 12 days without venting. Now CO2, of course, will go a lot longer. But Lin locks and lar, right? Nitrogen, argon, and oxygen will go 10 to 12 days without venting at all, with no use, no withdrawal.
2 cylinders that I remember hauling that were really heavy, CO2 and chlorine. Heavy, just heavy, you know?
Because both are full of liquid.
Yep.
They're both liquid. These are quick freeze. So remember I talked about that tube that goes down to the bottom in the argon? Well, we do the same with these. So these, we're going to have to heat shrink this again. Let's see.
That's okay.
See if I can get one facing the right way. I meant to have a snow horn out, but I didn't get it done. We'll come back and do snow horns. But this guy has a tube in the bottom of it. You got to be smarter than the wrap to get it off of there. And now this will step away.
There's a nylon bushing type thing that compresses into this ring right here that seals that off. It's one of the things that
when you put the 320 thread on it. So this guy, you're actually getting snow out of it. Instead of just vapor, right? Atmospheric gas, this you're actually getting snow. If you could capture it, because it's taking the liquid off the bottom and going right out. That's why they're so heavy. Again, 450 PSI, it'll be a liquid. CO2 will be a liquid. One other thing we haven't talked about is where do we get that argon, oxygen, nitrogen,
There you go.
CO2?
Where do you get your bulk liquids at?
Yeah. Well, we get ours from Messer, but and they're a great supplier. But where do they get it? It's incredible. It's the best business to be in, right? So here's what happens. They build an air separation unit.
Okay.
Right? Air separation unit is a bunch of compressors, essentially. I'm going to simplify this as best I can. It's a bunch of compressors, and they take air.
Our normal air in the atmosphere.
Just this stuff.
21% oxygen, balanced nitrogen, and a few other
and a
goodies.
little bit of argon.
Yeah.
And some xenon and that stuff, which you can't get to.
Yeah.
That might be one of those trace elements that was in that 99.995. So they take it and they filter it, clean it, right? And then they start chilling it. They run through a vortex and chill it.
Okay.
And chill it and chill it in this column, right? And the more they chill it, ice, all that stuff comes
Condenses
off.
off,
It's gone. But then they chill it down to about 280, 290. And what happens, just like fog in the air at the right temperature and humidity, oxygen condenses out of the air, falls into a trough, and the only thing that comes out is oxygen.
Wow.
Liquid oxygen falls into a trough, rolls off, and goes into a bulk tank. They scrub it, and they put it in dark tanks. And then they chill it some more, chill it, and you get to around 310, and you get argon. Condenses out and rolls off into a trough. God is cool. God is really
I didn't
cool.
know all that. That is cool.
And then they get to nitrogen. And once you get to nitrogen,
There's nothing else left.
there's no left. Yep.
Wow. Okay. I
So
didn't know
that's
all
how
that.
it comes. And then it goes off, it gets scrubbed, you put them into tankers, they bring it to us. But here's the great part, right? The great part. They bring it to us, we buy it from them, I sell it to you, you put it back in the air. You got it, you sell it, and you still got it. How neat is that?
You can't get any near that.
And then helium is the
I was
other
going
one.
to ask about helium. Helium is a diffraction of the natural gas business, is
Correct.
not. So why is there such a shortage of it?
Yeah, because you have to have what's called wet natural gas.
Okay.
What's wet natural gas? It has to have at least 3% helium content to make it worth it to pull it off. It's a very dangerous process because you're talking about natural gas and compression
and natural
friction
gas doesn't have any smell to it when it's coming out of the ground.
No, it does not.
And so it is dangerous.
So it's really dangerous. But it has to be a wet natural gas. So here we're talking about the cylinders come off the truck. They go right there, and they'll get, tomorrow morning at 6 o'clock, they'll start handling all those cylinders across to the other side, checking them, sniff testing them, ring testing them, and off they go. And rinse and repeat.
What's the new top? What's the new top that comes that you can put in place for?
Oh, there's a couple of
new
different
valve
ones.
system.
This is one. There's a vertical valve in Europe still. We haven't adopted it here. I don't think it's particularly safe to have a regular. It's tough enough going perpendicular, but going straight up, it's just hanging out there to dry. And then the bivalve. There's a cylinder cap that's a bivalve. So you put the regulator on and then close the cap back up, and you can actually lock it.
Yeah.
A lot of them have a hook and loop to lock them.
And you can also pick it up with a hoist.
Correct.
Yeah. That's one I think I saw.
Yeah. So if you have them on the truck, that's a good thing to do. So technically you can have regulators hooked up on a truck here if they're chained and in service. But realistically, every time you're done with your job, you take the regulators off, you cap the cylinders, and you transport. Right. I don't want to be on the other side of somebody who has a wreck and that regulator comes off, because that little band that's holding it together, like you said about brick walls and human flesh,
doesn't know the difference.
It doesn't matter.
Do whatever it wants to. 180 pounds in static is one thing. 180 pounds in dynamic is another.
Is
whole
an entirely
different
different thing with 2,000 pounds of propulsion through, like you said, a half or 3/4 inch hole.
And it's fun watching the guys, the Mythbusters. Mm-hmm. I don't need to be in person.
Yeah.
I'll watch. I'll take your word for it.
Well, CO2 bombs, putting dry ice in water and capping it.
Oh yeah.
Don't do that.
I could have.
Yeah, actually we
couple of pieces of rice.
By the way, actually we should have done that. I'm sorry, but yeah, if you put CO2 in water and let it just, and if you have the cap off, it just, sublimates and sublimates and sublimates, and it looks really cool, and it looks like a cauldron kind of thing. But what it does to the water, it makes seltzer water.
It makes what?
Seltzer water. Club soda.
Yeah, club soda.
You have carbonated water when you're done because it's CO2
All right.
in water, and it makes lightly carbonated water.
Does it need to be sealed to do that, or
No.
just
Nope.
open?
You don't want it sealed.
Yeah.
Because
Sealed
it's going to keep sublimating until it explodes. So, and a lot of the pools now, a lot of the swimming pools, as I said earlier, alluded to earlier, that they're using CO2 instead of acid for pH balance in the pool. Why?
Maybe.
Because if you have too much acid in a public swimming pool, it's shut down for 2 or 3 days.
Yeah.
If you have too much CO2 in a public swimming pool, you have a public swimming pool full of club soda. It's okay.
It's okay.
The pH is not that far out
So
of
at
whack.
that point, it becomes a ool.
Ooh.
Welcome to my ool. Notice there's no P in it.
No
Keep
pee.
it that way.
That's right.
All right, there we go.
And done.
Gary Lichtenheld, is that correct?
Yes, sir.
Lichtenheld,
Well
wealth of walking knowledge in the welding world here for gases and supply. Been a pleasure.
And worth exactly what you paid for it, I'm just telling you.
There you go. Been a pleasure. Thank you very much.
My pleasure. Thank you. You're welcome here anytime. Anytime.